People on in this meeting are GIS specialists. Actually, everybody excluding myself. Actually, I'm looking a lot to GIS, but I'm not a specialist like the other guys. And I think at the end we will allow a lot of time for discussion, or some time for discussion to say how can it be helpful for us as a gas transport company, an asset owners company. We've done some sniffing with vGIS on some projects, and we were reasonably enthusiastic, actually, not too enthusiastic, but fairly enthusiastic. But we also see some progress on your end, which make it maybe more profitable for us as a company, or the contractors who work for us, or the engineering companies who work for us. So that's shortly or briefly our position, actually. So we're within Gasunie. We have about 17,500 kilometers of gas pipeline network with compressor stations, valve stations, and all the things which go together with it in Germany and in Holland. You know, we are in very different identities of energy, city heating, hydrogen, gas, CO2, etc. Let's roll on in the presentation.
Excellent. And I will jump right into the presentation, but before that, I will give you a quick introduction of our familiarity with Gasunie, because we met with your team in September when we were in the Netherlands for the ESRI-UC. We had an outing. We had an outing where we showed the system in the field. We also work with some of the subcontractors that install infrastructure for you. So, for example, Van Gelder is an active user of vGIS. HDB is an active user of vGIS. Sears, some of the other companies that we're working with, like MUG, Royal Boskalis, and Stedin, they all use vGIS in different capacity. The presentation that I have today will cover two aspects, because our understanding of Gasunie is that you have a lot of infrastructure projects, especially going into the hydrogen, switch to hydrogen, and also the massive pipeline that goes from Rotterdam to The Hague. So we're going to present you two aspects of the system, how you can benefit from what we have developed as the owner operator, and how you can deploy it as the tool for some of the capital improvement projects that you have on the go. Feel free to interrupt me anytime. I will be happy to pause during the presentation and answer your questions. And we will distribute a recording of today's session after the call, along with other supporting materials that you may find useful. So vGIS is the company behind what we now call vSite. So vGIS is the company name. vSite is the recently developed platform that we've incorporated vGIS AR into. We've been building this product and this platform for 7 years now. And during that time, our company developed really strong relationships with multiple industry leaders. So we are partner of ESRI, we are partner of Autodesk, Leica, and several other companies. And the product was recognized by multiple global awards, including ESRI issuing partner award for us during last year, and Microsoft naming us as their top 4 developers globally for 3 years in a row. What we're trying to solve with this system, or what we're trying to do with this system, is we're utilizing visualization techniques to give you a better understanding of the conditions on site. And that understanding can come from viewing site almost in real time from the bird's eye view or from the ground level. And our goal is to complement your existing systems that may store that data in different formats, different visual kind of types, and combine it into a geospatial hub accessible through the web and accessible in augmented reality to give you much better understanding of what's happening at the particular job site. The challenges we're solving with this system are quite common on to construction, but also to operations, is fragmentation of data. So most companies use different tools and techniques to monitor the construction sites, including ground penetrating scans. They fly drones to collect point clouds. They have BIM models. They have eventually GIS data. And all of that data is typically resides in fragmented or siloed environments, sometimes on desktops, and rarely it is accessible to the people in the field as one. So people quite often have to deal with paper-based drawings, sheets, and plans to build off or to validate things in the field. What we're trying to do, or what we're doing with the system, is we're combining all available information into a digital twin available 24/7 on any web-enabled device, and that works together with our engineering-grade augmented reality to complete certain workflows that only augmented reality can accommodate. So vSite is a combination of two tools. It's the same system, but two ways to look at the same data. One is the web-based digital twin, and another one is survey-grade augmented reality that allows you to view data from the ground level. AR probably is what we are most famous for, and originally we designed it for utilities companies such as Gasunie, owners operators. The basic premise behind the system was, what if we take data that typically underpins traditional maps and display it in 3D? And the transition from 2D to 3D, the benefits of that transition are quite evident, because it gives you much better understanding of your job site. It gives you understanding of where things are and how they are arranged in space, how they interact with each other. It also helps you spend less time studying the map instead of focusing on the job. And it helps you avoid preventable mistakes, such as mistakes during utility locates. When our system works with GIS data, and this is what most commonly used by the owners operators, we can connect to your Esri ArcGIS backend and read feature or map services dynamically and convert it into 3D model on the fly. So the model you see right now on the screen is not created by human, but it's dynamically generated by the system based on the attributes within your data set. And that enables us to work with, first of all, dynamic data sets, so your data can change, and our system will automatically inherit all the changes. It also allows us to work with really vast networks. So for example, in Netherlands, because of the click system, we have access to the entire country wide of data in Netherlands, and we can visualize it alongside with your GIS information. So
Alec, may I ask a question on this?
Of course.
We did have some experience with vGIS with the position and the latency of the positioning and repositioning yourself. We saw it in Delft when you were over in September, that your delay was very short, actually no delay. And I know Chaco Smit, he worked with MUG in Holland, Mug, who also works with vGIS, had some not so positive experiences that there should be some rework on the software to speed it up. And the latency in the data processing in the field is not an issue anymore, is it, Alec?
Not to my knowledge. What we can do is we can pick a specific example. If you have any concerns, we can pick that example and we can validate it after the call. So we can, well, not today, not during this session, but if you can send a specific example, we can test it out and see if there are any latency, because I'm not aware of any problems. Occasionally, of course, depending on, let's say, availability of your data in your GIS database, or performance of ArcGIS, or latency across the global internet, there could be some challenges, but they should not affect user greatly.
If I can jump in right there, I had some experience last year. You allowed us to play around on a certain use case on Ommen. It worked fine, but we needed to calibration often, and maybe Cybrand, you're referring to the calibration as well, if you're talking about latency.
Correct. The signal, the updating of, yeah, correct. Yeah.
Okay. So for calibration, there are two ways of dealing with that, because we have several positioning methods. One method is manual positioning. And if you do manual positioning, the system may drift out of sync as you start moving around in space. Another option is to use QR codes, which is better suited for smaller sites where you can maintain that presence on site, but you will still experience a bit of a drift. However, if you use GNSS devices, so this is the typical setup we have. We use Leica, so this is the most commonly used device, and we use it usually in conjunction with an iPad, and it can snap on the iPad like this, and this will lead to the experience I'm going to show you on the screen right now. So if you can still see my screen, I will exit the presentation for a second. So this is how the system will behave with Leica. It will ask you to take a few steps, and in about 5 to 10 steps, it will recognize where you are and which way you're facing. The accuracy of alignment will be 1/10 of the degree or better. And while you're moving around the job site with Leica, so in this case, Leica is connected, your visuals will stay planted and continuously adjusted to a centimeter level accuracy. You will not need to recalibrate as long as you use external GNSS. So this is a good example. Here we purposely confuse the system by spinning around, which interferes with it processing augmented reality. And you can see that everything drifted out of sync. So you don't recalibrate, you just simply start moving, and the system will snap everything back into alignment. So calibration might be a challenge only in difficult light conditions when you don't use GNSS, but GNSS solves that problem almost entirely. Does it answer your question, or should we elaborate more on that? Should we jump back into the presentation?
Jump back. Yes. Just go back to the presentation, Alec. Yeah.
Awesome. So in addition to GIS data is where we started, and we are really strong at processing it. We can also work with BIM data. So if you have a sophisticated project, like for example, that pipeline from Rotterdam to The Hague, you can visualize all the BIM information with high accuracy in AR. So BIM information will give you a visual sophistication that GIS system may lack, but BIM models, they typically georeferenced accurately with depths and everything and proper shapes and dimensions. And you can use it as the guide for excavations, for planning, and several other things. For projects of that nature, you can also visualize earthworks. So our system can display proposed profiles and existing profiles. So if you have a subcontractor that has to cut or fill, you can visualize the discrepancies, and they can easily identify what they need to cut or what they need to fill in the field. And going one level above, if you, I know that you're focusing on the subsurface utilities, but if you have any assets above ground, such as pump stations or any above ground objects, we can visualize BIM information for those objects as well. We can work with Autodesk Construction Cloud if you store data there, or Bentley, or if you have IFC or Navisworks models that your design consultants provided or general contractor is using, you can visualize the same one alongside of your GIS data. So you will get a single digital twin of all the data you make available for the user, including the above ground structures, all your GIS data, click data, all in one view.
And what if you're indoors, because this is a construction site and it's all open?
Yes, indoors we can use QR codes. So we have an option for QR codes. We're also working right now on integrating Magic Leap, which is holographic goggles, with Leica Total Station. And that can give us sub-centimeter level accuracy. So this is something that we have an R&D project right now. That will give us sub-centimeter level accuracy for indoor projects as well. So in addition to GIS and BIM data, we can visualize reality capture. So if you fly drones, or if you perform scans with Pix4D or similar tools, we can display those scans after the fact with centimeter level accuracy on site, so that you can use it as a reference for excavations or for validation of utilities. It works exceptionally well for any open structure. So if you had an open trench, if you had trial trenches, which is what HDB used with Gasunie, so scanning trial trenches, modeling them, and visualizing them in AR. So AR is the prime candidate for that. You can also use it for enclosed structures. So in this example, we visualize manhole, and we work with Toronto Water to convert inspection videos that they collect for manholes into 3D objects associated with GIS data. So instead of point on the map, their employees can see the actual manhole that exists under the cover. To ensure high accuracy of positioning, we work with different positioning tools. So that addresses that problem with the drift and calibration that you mentioned. We can work with our primary partner is Leica, so we can work with this type of devices. We can also work with receivers of this nature, which is VDoc. So it's just a node onto your phone, a very convenient device that snaps on the back of your phone and delivers centimeter level accuracy for the AR visuals in the field. We can also work with existing surveying equipment, and we have an existing integration with Leica Total Station. Leica is our primary partner in that space. However, we work with about 40 different receivers. So if you have Trimble, if you have VDoc, Emlead, or some other receivers, then we can likely support them as well. We also can work with manual calibration and QR codes. We're experimenting with another method that will allow us to go QR code-less for indoor construction sites. And that gives us ability to work both indoors and outdoors. So to your question, Ronald, indoors, you can scan a couple of QR codes. So for example, if you have a subsurface station, in this case, so this is the pump station for a sewer plant, right, and you can visualize the entire BIM model overlaid on top of the physical world. And when you work around the job site, you snap on GNSS, and the system will maintain that centimeter level alignment as you move around the job site, and it will continuously realign and correct the model to make sure that it stays within that centimeter level tolerances. We recently, and we did a preview for Gasunie and Esri group in September. We recently introduced digital twin to the mix. So digital twin allows you to take your BIM model and all the available information, and then it places it in geographic context. The benefit of doing that is you can see not only what you're building, so if you have a capital improvement project, but also where you're building it. So the person in the field, they're not wandering around. Of course, they can use paper-based sheets and the plans, but the person in the field not wandering around, they can use that as a planning tool. You can use it for the tailgate meetings. You can use it for safety briefings. You can have a personal planning done while you commute into the job site. And sometimes you can even use it as a replacement for AR, because it gives you all the tools for kind of setting up offsets and creating annotations for yourself so that you can plan your day in it. And then when you're standing on site, instead of using AR, you can align yourself with the world in the digital twin space, and it gives you very good indication of where you have assets.
So yeah, like the 3D meshes we produced or have produced by Kavel team, the aerial photographs and the 3D meshes of it. That's no issue for you. The data is, of course, rarely large files, but your system can accommodate those.
So point clouds are coming. So for point clouds, we're scheduled for development and release in early Q2 of this year.
Cool. So he's talking about the layer package, the mesh layers from Esri. Are you also supporting that?
So the mesh layers from Esri are supported in AR, but not in the digital twin yet.
Okay.
So in AR you can visualize it, but in digital twin we plan to do it probably right after the point clouds. So once we start accepting native point clouds, after that we will introduce scene services and meshes to the digital twin as well. But it's available already in AR, so our system is capable of processing it.
I will be wondered about how we will deal with point cloud, but that's for now, I guess.
Yeah, and for point clouds, I would suggest to set this topic aside because there are multiple angles to attack that conversation. And we have several items on our roadmap that I would discuss specifically on the point cloud, but it's a big topic in itself. So I'll recommend schedule a separate conversation on that. So because digital twin and AR is part of the same system, once you connect data to one, it's instantly available in another. So if we did planning in digital twin, then I can step out on the job site with my iPad and see the same data with high accuracy AR. Digital twin, you will find, has greater utilization with field crews because it's easier to use, it's much more accessible. You don't need to have positioning devices or do a calibration. So in many instances, probably 9 times out of 10, field crews will prefer digital twin because of simplicity and accessibility. However, AR has a very distinct use case the digital twin cannot address, and that's why they're mutually complementary. So if you look at this screenshot, this is our project with McCarthy in the US, and they installed the pipe about 1 meter to the left, and their model hasn't been updated. So digital twin allows you to detect such situations where you have deviation from the model or where your GIS data doesn't meet the physical markings. It allows you to report such scenarios. It allows you to collect data and close such gaps. So AR is very useful for high accuracy validation. And digital twin is very useful for just as a reference tool when you're standing in the field. And both can use interchangeably. Another component of the digital twin and AR is that we build a task-based engine or issue engine that allows you to assign issues or tasks around the job site. So unlike traditional tools for issue management that gives you information about what you need to do, our system also shows you where it needs to happen. So if you click on any issue, it takes you directly to that space so that you can see what you need to do and where. And the same issue is available in high accuracy AR. So you will see tags hovering in the air guiding the worker to the specific location where they need to perform something. We designed the entire system for integrations. In fact, we're working with, I believe, one of your subcontractors, Van Gelder, right now, to allow us to integrate it with Esri. So we will have an Esri interface shortly. And in progress, our integration with Autodesk Construction Cloud and Procore. We also open for custom integrations. So if you have some ideas for how you want it to be blending into your workflows, we definitely have capabilities and we're open to discussing it with you. Once you get to the, sorry, it looks like somebody had a question.
Me, Alec. So can you, maybe you are going to, but where is this data stored and how is it protected? Because our data is quite sensitive, so to say. So how do you address that? Because actually, I believe you do some kind of syncing to your own system, right?
We have 2 ways of consuming data, GIS data. One is we do syncing, yes, and we do some caching. And the second option is real-time. Real-time is a completely pass-through system, so we don't store any information or don't do any syncing. So we just display it directly from your GIS database. We have a server in Germany. So we have servers in the US and Germany. So for European customers, we have an option of hosting in Europe. So right now we have a single solution in Germany.
And what is the minimum data you want to have served that we can see the solid pipes, solid network pipes? Is it like we can have we have measured the top of our pipelines?
So
we provide also the outer diameter. Would that be enough?
Yep. So we will use any attributes that we can find in your data set. So by default, we will apply something based on your standard, based on your internal standards. So if you have a pipe that is 1 meter in size, we can say default is 1 meter, but check this attribute within your data set for the actual diameter. So if you have an actual diameter, we will use it. If you don't, then we will use the default. Same goes for depth. If you have Z value, we will display the pipe or the line precisely at that depth. But if you don't, we can use one of the attributes to read the depth and apply it to the entire pipe. Or if you're missing that, we will apply the standard that you have for this utility type, and then you will still see it at depth. So there are different ways of handling that. So one of the things that you have probably have not seen from us in the past, because it's fairly recent development, is now AR part of the workflow. It's not a standalone tool that you just use to see stuff, because it has use case, but it's very limited use case. We also enable you to complete tasks with AR so that you can use one tool for seeing things and also completing tasks. So one of them is, for example, producing field report. If I am assigned task, like I was showing you in the previous slide, where I see what needs to happen and where, I go to that location, and now I want to report back to the office. In our tool, now in AR, you can click on field report and start simply taking pictures. While doing so, you can add voice notes or written notes. And as soon as you click save, instantly those images will appear in digital twin as oriented images. Oriented image preserves not only what happened on the site, but also location and the vantage point of the image. So based on the angle of the image, you can clearly say, okay, so manhole is misaligned, and I'm not asking for additional information because I know which manhole. So we have another example for this construction site. We actually moved one of the manholes, and we took a physical image that, okay, so green manhole no longer exists, it's been paved over. And here's the couple of images from different angles, and you're not wondering which manhole, you know exactly based on the angles of the images which manhole it is. So a single image can tell you much bigger story than multiple emails and multiple images that you can receive today. Another component that we currently have is LiDAR scanning capabilities. You can utilize vGIS and the LiDAR scanning built into it, so it works on iOS devices, to scan objects that are up to 5 meters away from you. So you don't have to go into, for example, this deep trench. You can see what you're scanning in real time, and the scan is processed on your device so that you don't have to wait for hours for photogrammetry. So you can see the results immediately on your iPad. And when you're satisfied with the quality, you click on share. 30 seconds later, it will appear in digital twin. And it will be combined with all your assets in the field, BIM, GIS data. And the person who otherwise would have had gone to the field to do investigation and measurement themselves, they can simply request this information from somebody who's already in the field, and they can get information they need through scans and oriented images without physically going on site. And of course, any scan that you do in vGIS will be available in AR later on as the guide and reference, so that you can use transparency slider, overlay it on top of the physical world, and get information about your lines and pipes. And in your case, it could be especially valuable because some of the gas lines or hydrogen lines, they can be unpredictable in terms of the shape. So it makes a lot more sense to store them in a 3D scanning format as well as a GIS format, because 3D scanning gives a lot more information about what's actually happening under the surface of the road. It's also a valuable tool for capturing before and after different stages of construction. So in this case, we have a trench before it was covered and after, and we can easily compare the two and identify any discrepancies that have happened from the time that it was excavated to the time it was covered. Together
you get an awful lot of amount of data, Alec. You have to store it all, and it's a tremendous amount of data. Or am I wrong in that?
Well, it's we have prioritization capabilities. So data management component is one of those things that make system useful, not useful, because having too much data is almost as bad, if not worse, as having not enough data. because if you are flooded with information, then there isn't much you can do. We have different techniques embedded in the system that help you prioritize data that's available just for that segment of your job site. So you are not overwhelmed with having too much information in your view. So you're always concentrating on something that's relevant for you at this particular location. And one of the things about this particular view, so here what I wanted to tell you is, if you use combination of oriented images and LiDAR scans for any, even the smallest project or largest project that you run, you can create an extremely detailed archive of what happened over time and where. And you can store that archive as an owner, operator, for future use, for future projects, which will simplify your discovery stage, engineering stage, as you will have very detailed information about your infrastructure from the previous project. We're working with one of the companies, one of the contractors, Van Gelder, on building an interface, because they collect data using our data collection tools and scanning capabilities. So we're currently working with them on an interface to make Esri as the permanent storage, so that you collect data, you can see it in vSite and all the time in AR, but ultimately the permanent storage becomes your Esri. So if you want to reference something in the longer term, Esri will become your storage solution.
You mentioned that, I think, if I remember well, you're working on a integration with ESRI platform to do something with this reported issue. And also, how, if we don't want to use ESRI for ArcGIS for that, if we want to use any other platform to merge these issues in, do you have something like an open API platform for this that we could use of, or what are our options?
So we have an API for that, and we designed it so that it's compliant with BCF format. We also have a technical group that can assist you with integrations. So it's because of much of the components are already complete, so it's just a matter of shaping them in the way that's compliant with what you have, building the sync. So we could be definitely open to investigating that.
Maybe which is actually aside to the notion on data storage. If you would suggest this platform for Gasunie as a solution, we're talking about the whole Netherlands and lots of pipe work and lots of stations, so to say. Would you dare to say that you could provide in that, or would it be too much data? Because that's actually going to be big, so to say.
Yep. We can discuss specifics around what you mean by permanent data storage and how big it should be. So our typical and most common arrangement is that you maintain some commonplace solutions as your book of records. For example, you will maintain Esri, ArcGIS, or QGIS as your permanent storage of data. And for BIM models, you may utilize something like Autodesk Construction Cloud or SharePoint for storing models, and we become a digital hub, like digital twin hub, that takes data that you permanently store elsewhere and places it into the digital twin. So that's more common arrangement. We can discuss some techniques we can use for permanent storage, of course, and there are options available, so we will be open to that discussion. Any other questions before we move on to probably some interesting topic for the owners, operators? So that should be fairly exciting, because this deals with pipes and lines. We have GIS data collection capabilities right in the system that allows you to simply trace utilities or lines, allocate marks on the ground to collect geospatial data. And this is what Van Gelder uses our system for right now, because this method of data collection significantly speeds up and simplifies data collection process. Especially with Van Gelder, we are right now implementing a process where they collect a line walking from point A to point B, just like you saw me doing in the video. Then they turn around and they perform 3D scan with the same tool going backwards. So in the time that takes them less than conventional methods, they get vector data for ArcGIS and they get 3D scan of the same utility, which is very elegant workflow and useful for owners, operators. And the same data is instantly available in vSite, in Digital Twin. So if somebody collects data right now, several seconds later, you can refresh your browser, you can view the data, you can export and use it for planning or import into your GIS database.
So Alec, maybe the video was a bit confusing, because I would say that this is very useful when you had your trench open and you have your pipeline installed, and then you say collect data, you walk back and do 3D scan, and then you have the right data. Because in your video it shows, okay, I do it just in a line on the pavement, which doesn't really make sense. Is that correct? Is my assumption right?
Correct. So the video shows you the vector data collection.
Yeah.
And in this case, we're addressing specific use case when the trench is already covered, but you identify based on the locate marks. So you hired locator, they spray painted the ground.
Yeah.
Now you know the locate marks, and you can update your GIS records based on the locate marks. But obviously, the best way to do it is the way Van Gelder does it, or the way you mentioned it, which is the same thing. When the trench is open, you trace the line by walking through the trench, and then you do a 3D scan at the same time. And then you have vector representation for your GIS data, and you have 3D representation for engineering purposes. Finally, last thing about the system is very useful as a collaboration tool, because you can share your screen, you can display what you see in real time to somebody else. And if you need an expert opinion, instead of bringing the person into the field to assist you, and all the delays associated with that, you can simply share your screen and get their feedback in real time when they can see what you're doing in real time, both physical world and augmented reality overlays. And for the sessions that we have right now, when you have a large group, instead of physically bringing everybody to the field, which can be disruptive and requires prior planning, you can have a single technician on site who works around with the GIS system, broadcasts it from different angles, while the rest of the group can guide them to a specific location around the job site so they can show it from different angles. So it's a very useful tool for collaborating. And another collaboration capability we recently added to the system is the ability to store viewpoints in Digital Twin. Because as you rightfully mentioned, you can accumulate tons of scans and images and other information in the Digital Twin. It may be overwhelming for the user to use. So what we have is you can open what you want the person to see and find the optimal angle and save it. It just takes one. I will go back and save it by clicking the save button on the viewpoint. So 2 mouse clicks, and then you can click and share that as a link. And you can send it internally, or you can send it to external parties. And it would allow them to see the same 3D view, but they will start with optimal angle with things pre-opened for them already. So jumping into technology, our system supports both iOS and Android, although we will highly recommend to use iOS devices with LiDAR built in, because it opens up scanning capabilities, produces much better AR visuals and much better AR experience.
Let me just elaborate this a bit, Alec. I hope, Hans, you are in the meeting with your ears open.
Yeah, until so far I was pretty enthusiastic. But now
okay, now that's good. That's good. No more comments. I rest my case.
Thanks, Simon.
So we also support mixed reality devices. We support Microsoft HoloLens and Magic Leap 2. We aim to support Vision Pro as well. So we're currently soliciting interest from our customers. And Digital Twin is accessible from any web-enabled device anywhere in the world. The companies that currently deploy the system are owners operators. In terms of owners operators, we have City of Toronto, City of Los Angeles, City of Houston. We also work with quite a few design engineering firms and general contractors who work on behalf of those major projects. The main use cases that our customers address with the system is that it provides a geospatial hub or common data environment for them. Quite a few of our customers already have common data environments in Autodesk Construction Clouds or others, We help them take their data that currently resides in Dropbox-like format and place it in the geographic context so that you can see where you're building stuff, not only what you're building. Our system significantly simplifies getting information from the field to the person in the office, and that simplifies the RFI process. So entire RFI process is streamlined with oriented images and 3D scans. And that leads to the reduction of site visits, because if you can get information you need from the site by simply getting the right images and the right scans, then you don't need to physically go on site, and people don't need to wait for you to physically arrive there. System is helpful with utility locate optimization. We can work with click data in the Netherlands. In fact, we work with NetForce to integrate with click data through ArcGIS. So, and we can display click data for pretty much anywhere in Netherlands combined with your utilities data. Collaboration and remote support are simplified again with the system, and documentation capabilities we built in for LiDAR scanning and 3D images or oriented images allows you to document progress and is built for capital improvement projects. On the implementation side, the system can be a self-service solution. So you don't need our services to process, add, or modify data or devices within the system. You can be fully self-sufficient if you have resources internally. We also have capabilities for helping you with that. So in fact, we see a lot of demand right now for helping companies integrate system within their workflows. And effective last year, we have a consulting arm that can assist with such projects in a very efficient way. The architecture of the system is it resides in Microsoft Azure Cloud and connects to different systems through the interfaces we created. If you use tools such as Civil 3D for utilities, we have free plugins that you can use to publish data directly from Civil 3D, for example, into vGIS. And then the end user doesn't need to think about what data they're getting because the system decides it for them based on the job profile and the location. And for the typical project, we have a trial, and we've done a couple of trials with Gasunie. We can send you really good pictures with our common experience with Gasunie and HDB for trial trenches in one place. And for subscription, we have two options. One is the user license when we have named users. We also have a project license or enterprise license, where we'll give you unlimited licenses for specific projects for the entire company for unlimited projects, where you can use it internally or you can extend it to external parties. The advantage of the project or enterprise license is that it includes guest accounts. So those viewpoints I showed you during the presentation, you can share with external parties such as locate services, subcontractors. So they don't need to have license to vGIS because they can access the same information through the viewpoints. And that brings me to the end of the structured presentation. So if you have any questions right now it's a great time to ask them.
Alec, user management, is it done with Azure AD?
Not at the moment. So at the moment, we have our own user structure. Okay. But now, as we integrate it with ACC, we are contemplating having single sign-on so that we can pick up users automatically for enterprise and project accounts. Because before, it was purely named users in our system. Right now, as we shift to more towards the enterprise model, we need to have a mechanism for automatically creating and removing users. And we are currently just designing the kind of SSO component that would allow that to happen through SSO with enterprise systems.
Can I ask about these QR codes that you're using indoors? How does this concept work? Could you elaborate a little bit on that for me?
Of course. Our QR code process, so let me show you the actual details. Our QR process is different from other QR processes you might have seen. Our QR codes only contain coordinates of the QR code. So there are some tools on the market like Visual Live that was decommissioned by Unity last year that use QR codes, but they require you to take QR code and put it inside your model. We don't do this type of things because in the QR code, the QR code only marks the coordinates of the center of the QR code. So it can be placed on any angle, on surfaces, ceilings, floors, and so forth. Because when our system reads it, it's almost like GPS signal. It understands where it is in relation to the QR code based on the QR code size. It knows the center of the QR code, and it knows that relative to those coordinates, I'm here. And that's how our QR codes work. So the ideal workflow, Ronald, is that you have somebody on site with the total station measuring points, and then you simply print QR codes for those points, because this is the physical point. And once it's done, this is one example of using QR codes. So you scan one QR code, it's on the wall. You scan second QR code, doesn't have to be on the same plane, doesn't have to be on the same wall, as long as it's accurate. So you scan second QR code, and now the system knows your location and alignment in space. You load data. So this is a good example of the accuracy of the data. They scan the room. So this is done test by Leica. Now it loads the room scan, and you can see how well it aligns with the entire room. They have control point on the ground. You can see it's that within a couple of centimeters with the control point right here. So that's for indoor. And I think your angle was for the indoor. We also have QR codes for the outdoor, because if you work in cities like Amsterdam, for instance, where you have to be closer to the building, your signal might be obstructed by your GNSS signal might be obstructed. So this is an example from London, which will have similar conditions. And they simply, it's a busy street, so they cannot place permanent QR codes. They carry them with them, and they know which pits they marked with the QR codes. So they simply place it on the floor, then pick it up afterwards, and the system loads the data. Now, QR code is not as reliable of the method as GNSS, so there's no replacement for GNSS, but it's a second best alternative for situations when GNSS is not available.
May I ask a question?
Of course.
We just a couple of weeks ago, we've granted engineering contracts to 3 engineering companies in Holland. Is there a possibility for a period of 10 years, actually, is there a possibility that those engineering companies are serviced all with the same mother data from Gasunie to do their jobs as they have to do it with vGIS, and that Gasunie would supply a kind of a company account to those companies, to those engineering contractors?
Yes. So we have situations like that where we have one entity using vGIS and then extending it to others. So we will require a formal letter from Gasunie to that respect, because data privacy is what we value quite a lot. So we want to make sure that we have a legal agreement that allows us in writing to share your data with specific entities. But once that agreement is in place, which I assume already exists, then we can definitely accommodate that use case. So this is why we introduced that concept of the project or enterprise license, because it accommodates scenarios just like that. You are the enterprise owner of the system, but then anybody working for that project on behalf of your car organization is authorized to use the system.
Yeah, and it also can act like Van Gelder with contractors who work for us to do the installation of projects.
Yeah, and Van Gelder is very, very, very proficient with the system, and they have many good ideas about how to utilize it. So they, in fact, we have a Dutch user group which is meeting every 2 months, and we're meeting this Thursday. And Van Gelder is one of the key companies there. So we discuss things like, for example, Dutch language pack. So our system is available in AR in Dutch. We also recently added multilingual support for the portal and for the digital twin. So we will discuss it with the Dutch user group to make sure that it's in native language. And they have some good ideas about workflow. So Van Gelder is by far one of the most advanced companies out there.
Yeah, I know I've spoken about vGIS with him a couple of months ago. Okay, perfect. Perfect to see. I don't know if there are any questions left for everybody who's attending the meeting, because it's nearly 5 o'clock, and normally we stop at 5 at our end. At your end, it's the early start of the day, but at our end, it's end of working time. I don't know if there are furious questions for some people.
How big is your company, Alec?
So we're currently close to 20 people. So we're still very R&D heavy right now to accommodate that, but we are growing rapidly right now. And we see a lot of traction thanks to the digital twin, because the combination of vSite, so digital twin and AR, is really a powerful solution that addresses quite a few needs. So we are 20, but we continue to grow.
And where are you located then?
Toronto, Ontario, in Canada.
That's where you're calling from now. Okay. Yeah. Yep.
Yeah. Okay. Could we say we had a pleasant meeting all together, guys? And of course, Irina is also present, but it's always again a male world and not a female world. But
Is it family of you, Alec, or you have the same last name?
Well, 2 of us, yes, but the rest of the 20 people, they have very different names.
That's family business. That's all your children, you know. No. Okay.
Yes, so Irina is actually one of the co-founders of the system. So she's been with us since the business, and she's one of the key individuals in the company.
Okay. Yeah.
Yep. Okay. I cannot hand out a bottle of wine to you or a bundle of flowers, whatever. But I really appreciate your presence, Alec and Irina, to elaborate the system vGIS for our company. And well, we have a discussion internally every Tuesday, actually, I should say, every Tuesday at this time with a group of people. And next week we will discuss it again, and we have a small summarizing of this session. And my last question is: are you willing to do some more testing with some data, which we might provide for a certain location, out of respect from HDB for the trial trenches? That was very successful, actually. But some larger locations, we did it some time ago on Almen with Ronald Nieuwenhuis. But maybe we should do a pre-test or a new test again with the new updates of your application, Alec.
Yes, and right now we restructured the trial process to provide much more in-depth help during the trial, so that it's much more successful. And we can always engage our local partners in the Netherlands. So we work with MUG, we work with NetForce, and they're quite knowledgeable in the system. And we are, as it happens, to be frequent visitors right now to the Netherlands. So it's yeah.
No problem. Okay.
Okay.
Yeah.
Thank you.
Good.
Excellent.
It's 5 o'clock.
Enjoy your evening.
Have a nice time, a nice evening, and working days. Yeah.
Have a good one. Bye now.
Bye bye.
Thank you.
Yep.
Take care.